Let's jump right into this explainer. Today, we're going to demystify how the really heavy math of probability and statistics helps us actually find order in what feels like a completely random world. Have you ever felt absolutely 100% certain about a statistic, only to realize the math tells a completely different story? Well, we're going to explore how probability acts as a lens. We've got a macro lens to see huge overarching trends, and a micro lens to update our specific individual beliefs.
To kick things off, let's challenge your intuition with a classic puzzle. Imagine a disease is present in exactly 5 out of 100 people. A medical test is developed that is 90% accurate. So that means it correctly identifies 90% of sick people and it correctly clears 90% of healthy people. You take the test and you test positive. What are the actual odds that you're sick? Hold the number in your head for just a second. I bet most of us naturally jump straight to 90%, right?
Well, prepare to be shocked because you only have a 32.14% chance of actually having the disease. I know, it sounds completely wrong, but think about those 100 people. Only 5 are actually sick, and the test catches most of them. But here is the massive catch. Out of the 95 healthy people, the test's 10% error rate generates an absolute mountain of false alarms. We're talking about 9 or 10 people. So out of everyone who tests positive, the vast majority are actually perfectly healthy. This perfectly proves that our human brains are notoriously bad at raw probability.
Here is our roadmap for today. We'll be running through the intuition of probability, the law of large numbers, the central limit theorem, conditional probability, Bayes' theorem, and finally, the core of data science. Let's get into it.
Section 1. The intuition of probability. Why we need math.
Because honestly, a 90% accurate test yielding a mere 32% actual chance of sickness feels like a total glitch in the matrix. It absolutely proves our intuition is flawed. Without structured math, our brains just rely on mental shortcuts that simply cannot process overlapping probabilities or massive data sets effectively. We literally need these tools to find the truth hidden in the noise.
Section 2. The law of large numbers, the macro lens.
So what this basically means is that while a single isolated event, like a coin flip, is wildly chaotic, repeating that exact same event thousands of times creates a highly predictable average. The law of large numbers guarantees that as your sample size grows, your results are going to march directly toward the true mathematical average.
Let's look at this in action. If you flip a fair coin just 10 times, the results are completely wild. You could easily get 7 heads and 3 tails early on. But look at what happens at 10,000 flips. The law of large numbers totally flexes its muscles here. The probability that your average lands almost exactly on a 50-50 split is a massive 95.5%. So the larger the number, the stronger the magnetic pull of the true average.
Section 3. The central limit theorem, finding the bell curve.
Now, the central limit theorem is one of the most remarkable facts in all of mathematics. It states that as your sample size grows, the distribution of your averages doesn't just stabilize, it naturally, almost magically, forms a normal distribution. This means that no matter how weird or skewed your original data is, if you take enough averages of it, those averages will always create a familiar shape.
Notice how raw data, collected into bins, begins to reveal these underlying patterns. Now, in statistics, we have to be super careful not to manipulate bin widths just to fool people. That is exactly why density histograms, which base the area of the bar on the fraction of data, are often the better, much more honest choice for visualizing these emerging shapes.
Check out the visual aha moment happening here. 10,000 random draws perfectly track that smooth blue bell curve. This is literally the central limit theorem captured in a single image. The sheer chaos of individual random numbers has entirely surrendered to the beautiful symmetrical order of the bell curve.
To make this extremely practical, statisticians use the 68-95-99.7 rule of thumb. This means that if you have a normal distribution, 68% of your data falls within 1 standard deviation of the mean, 95% falls within 2, and a massive 99.7% of almost all outcomes falls within 3 standard deviations. It's an incredibly powerful mental shortcut for instantly understanding variance.
Section 4. Understanding conditional probability, the microlens. Enter Bayes' theorem. This formula allows us to update our prior beliefs using the likelihood of new evidence. In simpler terms, it's exactly how you should change your mind when you get new information. And believe it or not, this is the exact mathematical engine powering the spam filter in your inbox right now. It constantly updates the probability of an email being junk based on the specific words inside it.
Section 5.
Bayes' theorem in action, surviving the zombie virus.
So, imagine a widespread zombie virus infecting exactly 10% of the world's population. Scientists rush out a test kit. Now, the test accurately spots 90% of the actual zombies. However, it falsely flags 30% of completely healthy people as zombies. You take the test, and it comes back positive. Are you doomed?
Let's break this terrifying equation down into 3 really simple Bayesian steps. First, setting our baseline prior, which is the 10% overall infection rate. Second, factoring in the likelihood, the true positive rate against the false positive rate. And finally, calculating our posterior probability. This is the actual chance you are craving brains. Well, you can actually breathe a huge sigh of relief. A positive test only means you have a 1 in 4 or 25% chance of actually being a zombie. But why? Because the healthy, non-zombie population is 9 times larger than the infected population. That massive group of healthy people generates an absolute mountain of false positives, so many, in fact, that they totally drown out the true positives.
Section 6. The core of data science, uniting the lenses.
Modern data science is fundamentally built on this exact duality. We zoom out with the law of large numbers and the central limit theorem to find predictable, beautiful order in massive sets of chaotic data. And at the exact same time, we zoom in with Bayes' theorem to adapt to specific individual new evidence as it arrives. It is the ultimate combination of seeing the forest and studying the trees.
I will leave you with this final thought. If your brain naturally assumes a 90% accurate test means a 90% chance of infection, what other certainties in your life are just waiting to be completely debunked by Bayes' theorem? Every single day, we're bombarded with data, tests, and probabilities. By applying these mathematical lenses, we can finally stop relying on flawed intuition and start uncovering the real truth hiding in the chaos.